Hey guys, it's Miss Vinson. So what we're going to talk about today is our very first market structure. Now, a good chunk of what's left in microeconomics is talking about 4 distinct types of market structures. So let's talk about some of the characteristics of perfect competition. So perfect competition is a market where there's many sellers and they're all selling the exact same product, identical products. That's the perfect part. So they are perfect competitors for each other. Now we tend to see these types of markets with things that are plain, a lot of times in the agricultural industry where we might talk about wheat sellers or soybean sellers, corn sellers, broccoli, apples, oranges, those types of things where, it is what it is, what it is. The product they're selling is identical, but this isn't a secret. It's not like the sellers are like, shh, don't tell the customers, but we're all selling the same product. Customers know they can get the exact same product from hundreds of different places. If you know that you can get the exact same product from many different places, what is going to be the key factor in where you buy that item from? Probably the price of that item, right? So customers have a super strong reaction to a price change. And do you remember how we called that a perfectly elastic demand? We're going to draw that on a graph in just a second. One other important thing to know before we start drawing our graphs is that firms in this perfectly competitive market, the sellers in this perfect competition, they are considered price takers as opposed to a price maker. So let's say you're a strawberry seller. And so you wake up one morning and you're going to take all your strawberries and you're going to take them to the farmer's market and try to sell as many as possible. So when you wake up that morning and you try to figure out, okay, what am I going to charge for my strawberries today? What price am I going to write on my sign? You can't just make up any price that you feel like that day. You can't be like, well, I'm kind of feeling $6 a pound for strawberries today and just write that on your sign. Because if the price that you choose is too high, guess who's going to stop at your stand and buy strawberries? Nobody. Nobody's going to tolerate that high price when they know they can walk a little bit further in the farmer's market and get strawberries for a lot cheaper. Man, if we're that strawberry seller, how do we know what price to charge when we wake up in the morning? How do we know what to write on our sign? Well, there is one price that we've talked about that is a safe price that customers are okay with. Equilibrium price. For a seller, there is no safer price than equilibrium price. So here's what we're going to do if we're that strawberry seller. We can't just wake up and make our own price. We can't just wake up and set our own price for fear that it's too high and nobody will buy anything from us. We'll scare all the customers away. If we want to have a good day at the market, we're going to wake up and then we're probably going to check our phones and see what the equilibrium price for strawberries is in the market today. So I'm sure there's an app for that, right? Probably an app that talks about the equilibrium selling prices in a market. So we're going to look at the equilibrium price for strawberries and we're going to say, oh, that sounds like a good price to me. I know if I write that equilibrium price on my sign and charge it all day long, then customers are going to have no problem coming to my stand and buying strawberries from me. As long as I stick with that safe price, as long as I stay with that equilibrium price, then you know what? I'm going to have a great day at the market. I'm going to draw this picture for you right now. We're going to have 2 graphs side by side. The graph on the left is going to be the graph of the whole entire strawberry market. So we're going to have an upward sloping supply curve that represents all of the hundreds of suppliers in the strawberry market. And we're going to have a downward sloping demand curve. This demand curve on the market graph is downward sloping because this is not the demand that's facing one seller. This is the demand that's facing all of the strawberry sellers collectively together. So the market demand curve is just downward sloping. Well, we have our great big giant X, and it's very clear to us that we can see equilibrium price and equilibrium quantity in the market. Now, the graph on the right-hand side is the graph of one single seller in that market. So you can think about it like we're sort of zooming in on one of those individual sellers out of that entire market. Now, what are they going to do? We said they're going to wake up, they're going to check their phone, they're going to find equilibrium price, and they are going to take that price, and that's the price that they're going to write on their sign and charge all day long and never deviate from it. So notice how this is a horizontal price line or a horizontal demand curve on our individual firm's graph. This individual firm better charge this safe price, because if they change it slightly, what's going to happen? They're going to scare off all their customers. They're going to lose all their customers. So as long as they stay with this safe equilibrium price that they took from the market, that's why we call them price takers, then check it out. They're going to sell everything that they bring to the market that day. Their quantity demanded is just going to keep going and going. It's just going to be infinite. But if they change that price slightly, if they decide that they want to have it a little bit higher, then they're selling nothing. Now let's talk about graphs for a perfectly competitive firm. We're going to look at the marginal average graph for a perfectly competitive firm, and we're going to look at the total graph for a perfectly competitive firm. All businesses have production cost. And so our marginal average graph for a perfectly competitive firm is going to start off with something you're very familiar with, and that's our marginal average cost curves. So let's go ahead and draw that real quick. Now this is really familiar, right? We've done a lot of work with this and we understand how to read this graph, but notice how all the curves on this graph is the cost, cost, cost. Bills, bills, bills. And our goal is to maximize profit. So we need to have some revenue coming in, right? We need to have some income. So we need a revenue line. So that equilibrium price that you took from the market, that price line is your perfectly elastic demand curve, but it's also your average revenue. It's also your marginal revenue, but this only works for perfect competition. Well, let's think about it. Marginal revenue is the extra revenue you bring in from selling one more unit. If I am charging $2 for each pound of strawberries, then how much extra money am I going to bring in if I sell another pound of strawberries? $2. So for a perfectly competitive firm, we're going to add one line to your graph, and that is going to be your horizontal demand curve. Now there's a lot loaded on this line, and that makes it very convenient for you when you're drawing and reading these graphs. If you're trying to find your price, you just go up and hit your demand curve. If you're trying to find your revenue, you go up and hit your demand curve. AR or MR, they're all the same number. So for perfect competition, three terms are actually going to be the same number found on the same line. Your price, your average revenue, and your marginal revenue all equal each other. Now let's read this graph at profit maximizing output level. Remember our golden rule of profit maximization. Our total profit is always going to be highest when our marginal profit is 0, because marginal is the slope of total. And the only way to get your marginal profit to be 0 is for your MR and your MC to be the exact same number. So if we're trying to find where MR hits MC on this graph, we're going to look for where our Nike check, our MC curve, hits our MR curve, which right now is our demand curve. So look where your MR and MC hit. You can even indicate that if you want to on your graph. And then drop down to your quantity axis. And you can put something like a Q star if you want to. And this is really, really important to perfectly competitive firms. If you're a business and you're trying to maximize your total profit, then you have some control over your price and you have some control over your quantity. Oh, but wait. Perfectly competitive firms don't have control over price. They can't change anything on that y-axis. Why? Because they're a price taker. They're so small compared to the whole market that if they try to change their price, then they're just going to lose all their customers. So actually, perfectly competitive firms have no control over price. The only thing they really have control over is that x-axis, is the quantity that they produce. So the only thing they have at their disposal to try to maximize their total profit is picking the right amount of stuff to produce. So that Q star, picking that right quantity, is critically important for perfectly competitive firms. How do we read this graph? First, let's find our ATC. Go up until you hit your ATC and just read the number straight off. ATC is going to be worth $8. Now let's find AVC. Got that curve, so just go up and hit AVC. When we hit that curve and read off the dollar value from the y-axis, that's just $5. Now, if we want to find our average fixed cost, remember the average fixed cost is the space between those two curves. That's why they look like they're getting closer together. That gap is worth $3, so our average fixed cost is worth $3. Now let's find our marginal cost. Our marginal cost is going to be our great big Nike check. So let's go up until we hit our great big Nike check, When we read the dollar value off right there, that's going to be $10. So if we're looking for TC, we're going to do ATC times Q. Well, that's going to be $8 times 100, which is 800. If we're looking for TVC, we're going to do AVC times Q. So that's 5 times 100, which is 500. And if we're looking for TFC, then that's going to be AFC times Q. So that's going to be 3 times 100, which is 300. Now let's find our new terms. Let's find all of our revenue terms and all of our profit terms. First off, let's find our price. Well, the price is very easy to spot on a graph of a perfectly competitive firm because it's going to be that big old honking horizontal line that's just like glaring at you on the graph. So that's the price that you took from the market equilibrium, and that horizontal line is sitting there right at $10. Now, not only is that our price, notice that that line is also our AR and our MR, right? Our last revenue term is total revenue. Well, we know how to find total revenue. We've been doing it for like ever. It's price times quantity. Price is $10, quantity is 100, so 10 times 100 is $1,000 in total revenue. Now we got to find our profit terms. So if I am looking for average profit, then I am going to do average revenue minus average total cost. So that means my average profit is $2. Total profit is just total revenue minus total cost. So our total profit is $200. Then finally, let's find marginal profit. That's just marginal revenue minus marginal cost. Our marginal profit is 0. Sometimes students look at that and they're like, oh gosh, that's bad. No, guys, that is ideal. Because remember, if your marginal profit is 0, that means that your total profit is maximized. Now, very quickly, let's talk about the total graph for perfect competition. Now, our total cost curves, remember, are these weird backwards S-shaped looking curves that are always upward sloping. Just like we added a revenue line to represent the money coming in on the other graph, we need a revenue line to represent money coming in on this graph. Since it's a total graph, it's going to be total revenue. Now, when we draw our total revenue line, it is a straight line with a constant slope coming out of origin. Why does it look like this? Marginal is always the slope of total, and since marginal revenue is a constant number, total revenue has a constant slope. Now on this graph, how can you find the profit maximizing output level? Because there is no MR and there is no MC, so our profit maximization rule really isn't helping us on this total graph. Well, that's okay. Since we're trying to maximize total profit, think about what total profit is. It's the difference between TR and TC. And so literally on this graph, if we look for where the gap is the biggest between our TR and our TC curves, where that space is the biggest, that is going to be where our total profit is the biggest, because that gap is total profit. Total profit literally is the difference between TR and TC. And we'll label that Q star. Now, let's say that Q star is 1,000. First, let's find total cost. Let's say we go up to total cost and hit that, and that's going to be $7,000. Then we go and hit our total variable cost, and that's going to be $5,000. Next, we need to find our total fixed cost, and so that's going to be $2,000. So if we want to find ATC, we're going to do TC divided by Q. That's 7,000 divided by 1,000, which is $7. If we want to find AVC, we're going to do TVC divided by Q, which is 5,000 divided by 1,000, which is $5. And if we want to find AFC, then we're going to do TFC divided by Q, which is 2,000 divided by 1,000, which is going to be $2. Let's find total revenue. When you hit that total revenue curve, you see that your total revenue is worth $12,000. Then let's find our average revenue. So when we take that $12,000 total revenue and divide it by $1,000 of quantity, then our average revenue is going to be $12. Well, not only is that our average revenue, but that's also our price, and by default, we know that's also our MR as well, just because we know for perfect competition, those three things are always the same. So if you are looking for average profit, your average revenue was $12. Your average total cost was $7. So 12 minus 7 is $5 in average profit. If you're looking for total profit, total revenue was $12,000 and total cost was $7,000. And so 12,000 minus 7,000 is 5,000. So after practicing this a couple of times, it'll take you no time to get familiar and very comfortable with this. Alrighty guys, until next time, I'll see you later.